So today I will take you through a paper that just came out on the 7th of February of this year 2025 that is super interesting and gives us a glimpse of where the future of AI model development is going, especially with using methodologies like supervised fine-tuning and reinforcement learning from human feedback, and the limitation in having humans as the bottleneck in implementing such systems to develop super smart, super intelligent models that are beyond even human capabilities. Now, I will just touch on certain concepts for you to have an insight into them as we cover the paper. And by the way, this is a fun paper to read. It's not super technical, so I recommend everyone to do it. It is super interesting, and I think it is a differentiating kind of conversation or area of study within AI that needs to happen for us to go to the next phase of development. So I'll just introduce certain concepts, and as usual, I'll put all the links in the description so you can do your own deep reading at depth. I have a diagram that explains the whole thing for you at ease, so you can think about it. You can actually have conversations with people about it, so you have that quick understanding of it, and then do whatever reading you think is necessary that either piques your interest or gets you certain outcomes that you're looking for out of understanding such topics. This is the name of the paper, or the title: Scalable Oversight for Superhuman AI via Recursive Self-Critiquing.
Subscribe to Daddy's channel. The mic.
This is a paper done by researchers in China, and I think after DeepSeek, it's somewhere or some country where we need to maybe pay a little bit more attention of the studies and the papers they are putting out there. And the basic problem this paper tries to address is, as we develop super intelligent AI models that are beyond our capabilities as humans, how can we still be in the middle of supervising the fine-tuning of those models or giving them feedback as they do reinforcement learning? Is it something practical? Probably not. It's becoming probably a bigger barrier in developing these models, and at some point it might not be practical. So here in this paper, they're putting a potential solution, they're testing and validating that solution, and we have the outcomes, and it's super interesting. I just want to cover a couple of concepts, and then I'll show you my diagram that puts all of this in a very simple visual. And these are interesting concepts even to understand beyond this paper. So the first one is Ensemble learning algorithms or Ensemble learning models. And you can read through the details of these models and these methodologies, but essentially these are machine learning algorithm models that helps different outcomes of other models actually vote, so this is maybe the easiest term to put it, or decide on the highest probability prediction out of the potential prediction that model, that initial model generated. So let's assume we have a model that looks at an image and tries to predict what is in that image. So hypothetically, we have that model that is given maybe in a picture of an apple, and then it gets 3 predictions. So it sees 3 outcomes as the prediction for the content of that image: an apple, a ball in general, or a red ball, let's say, or a tomato. So we have 4 options. Now we have these ensemble models that will go through these 4 predictions and vote which one each model will believe that is the probability or best probability to be the right prediction. And if we get more than 50% voting on one prediction, well, the best odd is that's the prediction with the highest probability. So that's most probably the high quality prediction that we can go with. So this learning mechanism, this machine learning models actually help in the development of AI models to really, with high accuracy, enable the training process to really tell which prediction or give feedback to the model of which prediction is the highest odd of the prediction that we need to go with at certain steps or certain phases of development. And those are not new concepts. Those are machine learning models that are used either in regression or classification type of models to really tell which prediction we should go with. And those operate in so many ways. This paper here or this website here will explain it at a really good level. So either we combine predictions or we take an average of predictions. We either do it in sequence or over layers. So there's so many complexities in these models, but the essential thing to understand is that those are mechanisms to help us tell out of the prediction of a certain learning or testing process of a model, which prediction to go with to take it to the second phase or second part of development of a certain maybe AI model that we are building. And also here in this paper, they address the majority voting concept. And I will also link for you a page that really addresses the naive bias classifier algorithm, or what they call a naive voting. So this is something that you can look at and understand. But again, it is basically a probabilistic classifier, which means it predicts on the basis of the probability of an object. In simple terms, again, a different way or algorithm of voting that achieves certain results. So you need a combination of both to really be able to judge the outcomes that you're getting out of models. Now, let me take you through the explainer so we can understand what these researchers are putting forward as an idea, the interesting things in there, and believe me, there's super interesting concepts they're putting forward and super interesting ideas that maybe are not applicable today but could be applicable in the future. And this is where we go to the realms of sci-fi. So just let's look at that, and then we go to the paper and just poke around areas. I think if you read the paper, if you decide to do so, you need to go in deeply. It's super interesting. So let's look at this graphic here. So this is the core challenge. So current AI alignment techniques with supervised fine-tuning or reinforcement learning with human or from human feedback become untenable when AI outputs exceed human cognitive threshold. So it becomes a problem really when these models have more intelligence and more reasoning than humans can actually do. We are dealing with smarter than PhD level models now, and this is today. So imagine as we go forward, humans will not have the ability to really give feedback to reinforce these models or actually give them the data structures to do the fine-tuning. So this is a big problem today, I assume, which takes lots of efforts by these AI companies, but in the future it might not be simply a problem. It might be a deterrent from actually developing smarter models. So we need a solution to deal with it. And they go through two hypotheses to do a solution for this problem, or to generate a solution for this problem. The first one is the critique of critique. And critiquing a critique is easier than direct critique, extending the principle that verification is easier than generation. So basically, the best way I put it, or I understand it, let's say I'm a teacher at a school and I look across students, across many classes, many topics. Now each topic has its specialized teacher. Each teacher will actually test these students and critique their responses or their answers to the questions. As a general teacher, I will get the critique of those specialized teachers, and then I will give my critique on the student. So I'm judging the student only by critiquing the critique of that specialized teacher. So I'm giving feedback on the feedback I got from the specialized teacher. They say this is the theory that they want to go with and they want to test. That actually critiquing a critique is much easier and as effective as doing it directly to the response. So me as the general teacher actually going over all the specialized topic across all over the students and reviewing their response one by one, which is too much of a task. The other one is the recursive property. This difficulty relationship holds recursively. Higher order critique, so critique to the power n, becomes increasingly tractable. So fundamentally, I maintain high efficiency and it becomes more easier, and I maintain the efficiency of this process as I do more and more critique of a critique layers. So I can have the response, I critique the response, and then I critique the critique, and then I critique the critique of the critique, and so forth until power n of c, which is critiquing. And they did certain tests to validate these two hypotheses, and one time they did it human to human. So basically they got human to evaluate human outputs across responses and critiques and critique of a critique and a critique of a critique of a critique. They did it at these 4 stages. They got humans with the questions, humans generated a response, a different group of humans critiqued that response, and then another group critiqued the critique of that response, and then another group critiqued the critique of that critique. So we did it across, or they did it across 3 layers. And then this is really the powerful one. They did that with AI, so human and AI. And here, humans evaluated AI outputs and self-criticism on tasks where AI outperforms humans. Here, we got a task where AI outperformed a human. The AI actually did the response and the multi-layer critiquing, but the final critiquing, I think they did it only the critique of the response and the critique of a critique, and humans were at that 3rd level and they did the final critiquing fundamentally. And this was where the research is really interesting, where humans actually leverage AI to make them able to guide and develop models that are smarter than them by just looking at that high level already critiqued layer of data or response or critique of a response sort of thing. So we're looking at much simpler things as humans that we are able to reason with at our level of intelligence, but essentially we are addressing things beyond our abilities as human in reasoning and intelligence. The last one, which is AI and AI. So this is testing AI's capability to perform effective self-recursive critiquing. This is actually having one AI model critique a different AI model at different levels and giving those multi-layer critiques, where at some level an AI model can develop a higher intelligence AI model. This one is where we get to Skynet and the Terminator. This is, if we hit that level, this is where we should start getting worried. But at some point, development of AI, smart AI models will stop if humans are in the loop. I think even the human AI model is sustainable maybe for the next 2, 3, 4 years, unless it's really effective where humans can review the critique to the power of 100. So we are reviewing actually the 100th critiqued response coming from these models, and we guide the development of smarter models through that. Maybe that would work. If it doesn't work, this is the way to go, and this is the stuff of movies, the stuff of horror movies that we've grown up watching. So the key findings of this paper: higher order critique contributes to more effective evaluation than direct assessment. So this is a human to human. So it is more effective. So they validated through testing. It is more effective to actually assess a critique of a critique rather than assessing directly the response. So when they did these groups of humans, while maintaining the efficiency of that review, actually it was much more effective to do a critique of a critique rather than directly going deep and digging and critiquing the response, the first response from humans that we got. That is something they validated in testing. The other one is that recursive criticism enables human supervision even when AI outperform human for generation. So they actually proved that this recursive criticism system will enable us humans to really guide much more intelligent models or generate much more intelligent or capable models than our human capability. With this kind of algorithm or system, we can definitely do that today at multiple layers of criticism. So this is a super interesting and powerful output of this paper. So potentially companies struggling with this part, they can take this paper and test it and play with it, or play with the experimentation they've done here to try to apply it to their own models and see what they get. So we can have actually the process of the fine-tuning supervised or the reinforcement learning from human feedback much more effective, much more accessible, just because of deploying such systems into play. Lastly, and this is the good news out of the paper, current models show limited capacity for self-critiquing. So AI models failed to self-critique and generate more intelligent models. That is good news. So Skynet is not on the table yet, but all of this could change overnight. At least this is what I've seen the past 2 years. things move fast and we might get surprises at any moment of time. The implication or the conclusion of this paper is that recursive self-critiquing offers a promising pathway for maintaining effective oversight as AI capabilities surpass human abilities. There's a path forward out of this for that human-AI combination for us to really bring that system to bear in developing more intelligent, more reasoning capable models that are beyond our human capabilities today or anyone, because now it's a standard that we have models that are PhD or higher in levels of intelligence. And really think about it, if we have humans trying to judge these models, how complex and tiresome and hard it would really be for humans to judge these models or vet every response that they get from them. So this is the core of the paper. If that satisfies what you're looking for, you're good to go. Now I'll just take you through the paper, show you the important parts. If you're interested in reading it, you should really do these parts. I would recommend the whole thing. It's light type of paper, but super interesting. So let's go there. So as usual, I recommend that you cover in the introduction, you cover the high-level ideas that they put forward in the paper. So here you can see they are defining how they define a response, how they define a question, then how they define a critique and a critique of a critique. So they put it in also sequence of equations. So this is not an actual equation. It just shows you the sequence of the logic flow and how they look at it. So it will serve you well if you continue reading and looking into the equations that they later address and how they did the experiments to validate the two hypotheses they put forward in this paper. And then they talk here about recursive self-critiquing, and they talk about the protocols they follow. And if you carry on, you'll find this really interesting diagram that really explains things visually. And you can see you have a question, and then you have a pair of responses, a pair of critiques of those responses, and then intersection or crossing of those critiques of these responses. And this carries on to the critique of critique and keeps going until the higher order critique to the power n. Again, depends on the need. Now, the testing they've done for the most part was done to critique of a response and then critique of a critique. And the most I've seen in the experiment is critique of a critique of a critique. So basically, it's critique to the power of 3. That's the maximum thing they tested. In each of these layers, they are monitoring certain metrics that gives them insight about how at certain benchmarks the outputs are accurate. So they look at the accuracy and also they look at the confidence of those predictions. Now you can see here they look at the majority vote. So this is what we talked about the voting. So you can read about these machine learning algorithms, but this is their way to tell which is the highest probable prediction out of each layer of these layers of critiquing of these models. So you can carry on and read what they dig deep when they talk about majority voting, what they cover when they talk about the naive voting baseline, and then they talk about the recursive critiquing. And then if you carry on, you're gonna see each hypothesis and how they test it, and you can see the different benchmarks. So this page, they focus about the benchmarks they cover. So this is Chinese benchmarks of education in terms of math, language, and science. So you can read about them here. And if you carry on, you're gonna start looking into the data. So this is, for example, the first one when they do the human-to-human testing to experiment with these hypotheses. And you can see it goes into 3 stages: a response, a critique, and a critique of a critique. Again, each of these are different benchmarks, and you can see for each, at each level, how the accuracy, and here you can notice that the accuracy is increasing, the majority voting is increasing. So these kind of models that give us which prediction to go with are actually giving higher votes to the selected prediction, which indicates that the prediction that is being voted might or probably is higher quality type of prediction. And then you can get the naive voting and then the confidence. And you can see the confidence is going up and the time to give the critique or to give the response is going down. And I assume this system potentially will have its own computational cost, but it might become a necessity that we cannot avoid at some point. So you can see the details of the experimentation and what drove them to their conclusions. And also you can go to the next level of this and see how it happened when AI is concerned. So here you see there are 4 different benchmarks they looked at, and when they looked at human AI, they actually went to the critique power 3. So critique of a critique of a critique. And here they track the human accuracy, which is increasing, and also they track the AI accuracy, which is also increasing, and the confidence is increasing, and also time is going down for the most part. Sometimes it's not as drastic, but this one is where it's super interesting. And here you can read about the models that they used for this part. It is working. It is something that we can actually use as the next frontier in developing super intelligent models beyond our capabilities. We need something like that. And they tested it and it works, at least to this level of critique. And lastly, you can see even the levels of testing of AI and AI self-critiquing. And you can look at the details of it. So they did at again, similar to human AI. So they did at the 3rd power of a critique. So critique of a critique of a critique. And you can see the quality or the accuracy of these models just fall apart when we touch on the AI to AI kind of self-critiquing. And you can see here the accuracy and the majority voting is fluctuating, and it's not something that actually we can use or leverage to build models. This is only saying that AI models today can't self-critique to create more intelligent models, which is good news as far as I'm concerned today. So here you have it. Super interesting topic. I think this paper or this concept will be really pivotal as we go forward to producing more intelligent models. There's no way out of finding a solution for this problem of dealing and navigating the development of models that are beyond any human's capabilities. So we need systems to help us do that, regardless through supervised fine-tuning or reinforcement learning from human feedback. If humans are involved to give us that kind of more intelligent models, we need systems to help those humans to be able to deal with that superior intelligence to a certain extent or in certain domains. Again, you're going to have all the links in the description if you want it. All in all, if you enjoyed it, don't forget to like the video, subscribe to my channel. Most importantly, give me a comment. Tell me, what do you think about all of this? Do you think they started playing in the danger zone? And with this, thank you very much for watching and goodbye.
Subscribe to Daddy's channel. Give me the mic.